So, by way of introduction for a really big idea of calculus, are you ready?
Yeah.
All right, so imagine you're driving to Kansas, okay, to see your daughter. And the speed limit is posted at 75, but you're going maybe 90. Right? I just gotta imagine you. People break the law. It's terrible.
I gotta break the law.
Okay, so you at 8 o'clock a.m. you pass a policeman. You see the policeman ahead of time, and so you slam on the brakes. And so when you pass him, you're going a nice, cool 75, maybe even 74. All right. All right. Now you put the what's the cops in your rearview mirror? You go back to your 90, and at 9 o'clock, you are exactly 90 miles down the road. Now, you see another cop at 9 o'clock, and you slam on the brakes, and again, passing that cop. You're going 74 miles an hour. Can he pull you over and give you a ticket, assuming he has a radio and he can communicate to that first cop?
Yeah, probably.
Yes. But when you saw the first cop, you were going 74. Is that the speed limit?
Yeah.
Yes. And the second cop, you were going 74. So, can they give you a ticket?
Yeah.
What? Got there so
I'd say
fast? Could you give me some numbers
What if
instead
there
of
was
so
traffic?
fast?
Because you drop them an hour, drop
yeah.
them 90 miles an hour.
Yours, okay, so is it that your average speed is breaking the law? Because my average speed was 90, or not mine, sorry. Your average speed was 90 miles per hour. Does that imply then, just because the average speed was 90 miles per hour, I must have broken the law?
Yeah.
So you're saying that if my average speed was 90 miles per hour, I must have gone 90 miles an hour
Yeah.
at some point. Yeah? Okay, that's the mean value theorem right there. Okay, the idea is that if you, under certain conditions, there must be a place where the instantaneous rate of change and at the risk of being redundant, which is to say the change at a point, equals the average rate of change. Which again, at the risk of being redundant, is the change over an interval. That is, in layman's terms, the mean value theorem. That's the concept behind the mean value theorem. There's got to be a place where the instantaneous rate of change equals the average rate of change. And it might seem kind of super specific and not very applicable. It's actually very applicable in a lot of ways. It's pretty great. The mean value theorem in more formal math notation might be this. If f is continuous on a closed interval and differentiable on the open, first of all, you must first meet the conditions first before using any theorem in higher level math. Before its use is demonstrated, you must say, hey, this is an applicable situation. Just like you wouldn't use Pythagorean theorem on a triangle that wasn't a right triangle. You can only use it in cases where you have a right triangle. You have to demonstrate and show, hey, this is the right situation for this theorem. Okay? There must be a place, at least one c value, that's an x equals c value. There must be a place where the instantaneous rate of change, or if you like, the tangent slope, if we think visually, equals the average rate of change, or secant slope, again, if you think visually. All right, now, a picture is worth 1,000 words, so let's draw a picture or two to show this idea. Would you graph or give me a quick doodle of a upward opening parabola that has different endpoints? So something like this. Now, A and B represent the endpoints. You follow? It's a closed interval. Now, if I were to draw, this to me is just one of the cool things about calculus here. If you were to draw all the slopes at all the points, which is infinitely many, and average all those slopes, the average of all those slopes, both some negatives and some positive, the average slope would be the same as this slope. This is the average rate of change for the secant slope. Now the mean value theorem says that if that's the average rate of change over the interval, there's got to be a place interior, which we'll call C, where the instantaneous rate of change or tangent slope is the same. Where would you say it is? Just to the left or the right of the vertex?
To the right.
A little to the right of the vertex. This point is the C, where we'd say that instantaneous rate of change is the same. Is that, yeah?
That's sick.
Cool. I love your energy. That's great. Okay, would you draw a cube that maybe has different y values? There's an A, there's a B for the left and right edge. Would you sketch in the average rate of change between the endpoints? Here's the secant slope, yeah? Where is there a place where the tangent slope is the same? Two places. Okay, there's a C1 there and probably a C2 there where the tangent slope is the same. So it's not even the case that there's has to be one, it could be several. The more turns there are, the more possible it is. You can imagine on a sinusoid there could be infinite. You with me?
Yeah.
All right. Now, let's talk why continuity is necessary. Would you give me the old graph of 1 over x? Y equals 1 over x is a good way to demonstrate this. Here is the 1 over x graph, yeah? And let's say, actually I should have not gone so far. Let's say the endpoints are A here and B here. So all the points in between are going to mean to go beyond that. You with me? Okay, now the secant slope connecting the endpoints would look like this. Where is there a place on the curve where the tangent slope is like that? There isn't one. In fact, all the points on these curves have what kind of slope? Negative, and you're looking for positive. There is no such place. There is no C, which is to say the MVT does not apply if the function is not continuous. This doesn't hold true if you have a break in the function. All right? Let's also talk differentiability. Would you give me let's do the old Siegel function like this, yeah? With a check mark, which is x to the 2/3 usually, okay? All right, well, I made one side bigger, so it's a kind of terrible Siegel. Yes, it's an asymmetrical symbol. All right, now, the average slope between these 2 points is like that, yay? And yet, there is no place where the slope is like that, and that's because the slope goes from strictly decreasing hard to increasing. So, differentiability, if no differentiability, then also MVT does not apply. That's not apply. It's got to be a smooth transition of all the slopes in between the endpoints to hit the average rate of change. All right, you with me so far? Okay, the first thing you'll have to do then when you do these problems is show the conditions are met. This has to be on every problem at that's MVT. It's got to be part of the work. So let me communicate so I don't have to take off one every time you fail to do this on the homework or test, what it should look like. It goes like this. F of x equals x squared, which you can imagine is the parabola, obviously. Is the parabola continuous on negative 3 to 3?
Yeah.
It is. You'll state that. F is continuous on negative 3 to 3. What about either the graph having sharp turns or the derivative, which is 2x? Does it have any issues in between negative 3 and 3? No, it's all good. F is differentiable on the open interval negative 3 to 3. Now, why the closed interval, open interval? Over the course of these four problems, I'll explain why closed and open. But just for now, get on the habit of, for continuity, it's got to be continuous through the endpoints. And that's because we use the endpoints to draw the slope tree. You've got to have continuity at the endpoints to draw the slope tree. Yeah? The differentiability doesn't have to be up to the endpoints because the point at which you draw the derivative is inside anyway. So we would say then that the MVT applies in this case. There would be a place where the average rate of change is equal to the instantaneous rate. That's what I want you to do for these four. Do you understand? Okay, go.
Tangent of pi over 2 is the design. Shadows.
Ready? Let's finish it. Okay, here we go. Step is tangent continuous on that interval.
No.
Steph, your voice is so deep. Steph, you say what? No. Okay, so this F is not continuous on the interval, and so right away the MVT does not apply. I wouldn't even go to the next one. Don't waste your time meeting another condition. If it doesn't meet one, then it's not applicable, period. Right? What about the next one? Campbell, is it continuous? Is the square root graph continuous on that interval? It is. Okay, so why? Make sure you get in the habit of using the name they give you. Don't just say, oh, it's always F. It's not F, it's Y here. F is continuous on the closed interval of 0 to 9. The derivative is 1 over 2 root x. Does the derivative exist on the open interval 0 to 9?
No.
Open interval.
Yes.
Which is to say, does not include the endpoints. Are we good to go at all the points between, but not including 0 to 9?
Correct.
We are good. Okay, so y is differentiable on 0 to 9, so the MVT applies. Now, this is a good illustration. I chose this one to illustrate the point of why open interval, why closed interval. Why does it have to be so far? Why can't they just say interval? Well, if you look at this guy, I think you'll agree that the average rate of change looks like that, yeah? And the fact that the derivative doesn't exist there because it goes vertical is not an issue because the C is inside anyway. So I don't care if the derivative doesn't exist there. The C at which I draw the tangent slope's interior. So it's all good. You with me? Okay. What about the last one? Is this has got negatives. Is that a problem in a cube root? No. Y is continuous on -8 to 8. Closed. What's the derivative? 1/3 x to the -2/3, which is 1/3 cube roots of x squared, yeah? Is y differentiable on the open? Does y exist at all points? I would throw out there, do you all agree? Do you agree it's differentiable on the whole interval? Ladies, back there, represent. Yes, you say. Thomas? Nobody wants to be correct? Yes, sir. Alex? 0, yeah, it's got a 0, it's got a denominator there. 0 is a problem. It is not differentiable at all points. It is not differentiable, at x equals 0. So MVT does not apply. Okay? Now, after meeting the conditions, then you typically proceed on with the problem at hand. Now, these are two different wordings here, and you'll need to get, this will be a verbal calculus problem. You need to read the code kind of thing, or decode it into the actual little decoder read. So it goes something like this. F of x is the square root of x. Must there be a c in 0 to 4 such that f prime at c is 1/2? If so, find the c value. Okay, when you get a must there be, if it says an f of c, in other words, must there be a y value, you should think, you've done that before. When I say, does there have to be a y value that's 2, what do you use there? IVT. Okay, when it says, must there be a place where f equals this or that, then think IVT. But if it says, must there be a place where the derivative is something, you should think MVT, because MVT is very much about where is the derivative. Right? So the first thing you're going to do is, okay, it must be one of those two, boom, derivative. So this is a derivative problem, you must be thinking MVT. Now, y/2, I have no idea. Where is this coming from? Not sure yet y/2, but I'm thinking it's probably the average rate of change. We'll get into that later, all right? It's probably the case that the slope of the interval is 1/2, and that's got to be a place where that's why there's a place where the derivative is 1/2. But we'll get into that later, don't worry yet. I'm already thinking MVT, so we're just going to go with the conditions. Is f, the square root function, continuous on the closed interval 0 to 4? It is. You must say that. Okay? On the AP test, that's the first point in the rubric. Meets the conditions for MVT. Is f differentiable on the open interval? All right. Therefore, by MVT we claim, so by MVT, there's really two parts to this problem. There's say why there has to be a place, and then find the place. It's really two questions. So by MVT, there is a C where f prime at C, I'll get into the derivative later, equals, now this is where I show the average. Remember, the big idea is instantaneous rate of change equals average rate of change. Instantaneous rate of change equals, what's the average rate of change for this problem I'm going to look at? Just setting it up. Don't worry about numbers yet. F at, don't worry about numbers yet. F of 4 minus, yeah. other words, you're doing the f of b minus f of a side, but with specific a's and b's for this problem. You with me? All right. Now, this is where I hopefully will see where the c is. What is f of 4? 2. What is f of 0? And so it seems like, oh, yeah, there's got to be a place where the derivative is 1/2 because that's the average rate of change. The slope between the two endpoints is 1/2. Now, I've done the first part of the question. Must there be a place where the derivative is 1/2? Yes. By IDT, I've proven that there must be a place where the derivative is 1/2. So first part of the question done. You with me? Now it says, if there must be a place, find the c value. Now I have to find the c. Well, what is f prime at c? 1. What is the derivative of square root of x? 1 over 2 root x at c. Okay. So f prime at c is 1 over 2 root c. In terms of notes, obviously on an AP test you wouldn't say, hey, this is f prime. They will know. Okay. Equals, and what is the average rate of change, or the right side of the equation? 1/2, yeah? If I solve for c, you can probably just do it by guess and check. What is c? Okay. So yes, there has to be a place where the slope is 1/2, and that place is at x equal 1, or c equals 1. You with me? Okay, try one on your own. While you're finishing, does it apply here?
Yes.
What about the absent one? On the interval they give me, it's not an issue. All right, so you can agree that f is, did you meet the conditions first? F is continuous on the closed interval. And f is differentiable on the open interval, yeah? So by MVT, there is a, did they call it a C, where sometimes they'll call it something else besides C. F prime at C equals, in this case, F at 4 minus F at over 4 minus 1. Okay? I have a little more work. I usually work down, not across like I did up there. I just didn't have enough room to work down. So I typically will work down and I will work both sides. What is F of 4? And F of 1 over 3. What is the average rate of change? Negative 1/4. Okay. The place where that happens is the left side, so on the left side I'll start working the derivative. What is f prime at x?
Negative 1 over x.
Negative 1 over x squared, so it's c?
Negative 1 over c squared.
Negative 1 over c squared, so I have that negative 1 over c squared needs to equal negative 1/4. What does that imply about c?
C equals 2.
C is 2. Okay, sometimes the algebra will vary and you can't guess and check, but that works here. All right, though it seems like the same question, it's slightly different. Try another one, please. Got a little different aspect to it that you need to be. Anybody want to see it?
Really good.
Yep.
Making graphs the only way to tell it's continuous.
No, yeah, good question. If it were an equation that I wasn't familiar with the graph, I would have to think about the problems with discontinuity, like 0 in the denominator, or negative in a root, or log of 0 or negative, but that's our ugly cases. You, at least for the AP test, should be familiar with it. Okay? You know cubes have no issues, and the derivatives have no sharp turns. Okay, so did you get something like, yes, it applies? You met the conditions, yes? All right, so there must be a place where the instantaneous rate of change equals the average rate of change, is what I think when I see this expression. What is f prime at c?
3. 3c. Oh, wait, my bad.
3c squared minus 1 is the instantaneous rate of change. What's the average rate of change?
3.
3. I get something like 6 minus negative 6 over 4. So I see where the 3 is coming from. 3c squared minus 1 equals 3, which means 3c squared is 4, which means c is plus or minus square root of 4 thirds, or 2 over root 3. Are both good to go? Both are in the interval, or no, only take one? They're both good to go. All right, you with me? Okay, let's try this from a slightly different angle. The book doesn't do a lot of table problems, so we will have to make sure that you see some so you're ready for the AP test. Not to mention, in real life, you often get data, not equations. So given the table of a differentiable function, sure there must be a k. Keep in mind right there, they're calling it a k, not a c, so make sure you use the problem they give you. Where k is between 0 and 7 such that f at k is 3. What do you read this as? What do we have to use? IVT. F equals a something, so probably IVT. Well, look at the table and use your IVT skills. Does it seem like there's got to be a place where y is 3, or f is 3?
It seems that way.
Yes, in what interval is it guaranteed to happen? 0 to 7, in the y values from 0 to 7, and what about the x values from 4 to 5? It seems like it's happening. But the conditions need to be met. Are the conditions for IVT met? What are the conditions for IVT? Yeah, you only know it goes through all the points from here to here and all the points in between if it's continuous. Does it say continuous? Does it imply continuous? Yes, okay. So, how would you say your justification for continuous? F is continuous because it's differentiable. All right, that's the first condition. The next condition is the between this element. Obviously, if they said, does there have to be a place where the y value is 42? That wouldn't necessarily be true. So the between this case has to be met. So something like f equal 3 is between what y values? And 3 is between, I'll just say, forget the f equals 3, I'll just say 3 is between -5 and 16. I was thinking a little more narrow, but okay. I'm going to go between 0 and 7. But you could say, you would definitely be fine to say -5 and 16. That's, actually, let's just do it that way. There's no reason why not. Okay, 3 is between -5 and 16, yeah? So there must be a, what? K, where, what? F at K oh yeah, sorry, by IVT. I should have put it, I typically would put it right in there. So by IVT, there must be a place, a K, where F at K is. You follow? Okay. Given the table, show there must be a P where F prime at P equals 3. F prime means the MVT. All right. Now, it doesn't have to be from 0 to 7. It could be any combination of points in between, and sometimes you'll have to hunt around for where's the slope exactly 3, but what about the points they give you? What is the slope between 0 and 7? What's the rise, or the change in y value? 21. And what's the run? 7. And so is the slope between the two endpoints equal to 3? Yes, okay. So it feels like MVT is good to go. Let's go there. First, meet the conditions. Is F continuous on the closed interval? It is, because F is differentiable. I guess I've already said that in my work. And F is differentiable on the open. So by MVT, there is a what? P in 0 to 7, where what? Okay, and then you need to show where the 3, you need to show them, hey, I know where the 3 is coming from. I'm not just going to say, yeah, it's got to equal 3, sure, why not? You're saying, I understand where 3 comes from. It comes from the average rate of change over the interval. F at 7 is 16 minus F at 0 is -5 over 7. That is 3. Okay. All right. Now, let's talk special case. Would you agree that a square is a special case of a rectangle? Cool. Now, Rollet is a special case of mean value. Would you follow these instructions, please? Sketch a function that's differentiable on a closed interval and f at A equals f at B. And then consider the question. Give that a sketch, please. Decipher that into calculus, decide what it means, and make a sketch that fits. Alright, so I don't care what kind of graph you did, but what kind of shape?
Sinusoid.
Parabola, sinusoid, okay, sounds good. Parabola or sinusoid would work.
I just wanted to do a sinusoid.
Okay, if f, you hear that? If f at A and f at B are equal, what does that imply about the endpoints?
That's
They have the same y value, yeah? Same y value. So whether that looks like this or this, that's awesome. So what would that imply about the MVT? Yeah, there's got to be a horizontal tangent. If the y values of the endpoints are the same, then the average or secant slope is 0. And if the secant slope is 0, there's got to be a place where there's a horizontal tangent, and it's probably got to change signs in order to get back up. So it's got to usually indicate a min or a max. Horizontal tangent. And that's pretty powerful. There's got to be an extreme in between the two is often how we use this to prove. But the idea is the instantaneous rate of change has to be 0 at some point. You can imagine how you could maybe use this to show that something's not moving because the derivative of position is 0 or something like that. It's useful in a lot of proofs. Now then, for Rollet, you have 3 conditions to meet. You first meet the first 2 MVT conditions and the endpoints equal condition. So if you get a Rollet problem, then it might be something like show by Rollet there must be a place where the derivative is 0. Well, you would start by saying for this function, the parabola, is it continuous on the interval?
correct.
Yes, f is continuous on the closed interval, -3 to 3. Is it differentiable on the open? Does it have a smooth curve to it? It's not sharp turns anywhere.
Yep.
Yeah, f is differentiable on the open interval. And the last condition for Rollet is to show that the endpoints are equal. What is f at 3? 5. What is f at -3? Now, if the endpoints are equal, then by Rollet, and just depending on the book, some have Rollet with a little accent. Some books even just have roll. By Rollet's theorem, there is a C where f prime at C equals, you don't even have to show the average rate of change. Because you showed the endpoints are equal, it's implied that the rise is 0. And therefore, there has to be a place where the derivative is 0. Okay, running out of room, would like to have done a softie, then a toughie, but I just went toughie. So, an ugly case. This is once in every blue moon, couple 3 years on the AP test. There's a doozy where they ask you to put several skills together towards preparing you for that. Use the IVT, then Rollet to prove there must be a C in 0 to 12 where the derivative is 0, given the table of a differentiable function. Now, on the AP test, they would never hold your hand through it like this. They wouldn't say, use the IVT, then Rollet. They just say, prove there's a place where the derivative is 0. But, breaking it down, doesn't Rollet depend on there being 2 the same y values? Do you see any of the same y values?
No.
Now that is a problem, okay? And yet, can we infer that there must be a same y value by connecting or thinking between the
Probably.
given points? Yeah. Give me a way to reason through this. Must there be another place where y is -2 later on?
No.
Okay. Must there be a place where y is 4 later?
Yes. Yeah.
Why? It comes back down from 7 to 5. Now 4 wouldn't be in there, but when it goes from 5 down to 1, it would have to pass back through 4, yeah. And you could do this a couple different ways, but that's just the first way that seemed to me, all right? Now, why do you say there has to be a place where it passed through and took on 4? IVT. And so you first have to show that there's going to be a place where y is 4, and then we can use MVT. So let's start with the IVT here. F is, what's the condition for IVT? Continuous, because it's differentiable. Because F is differentiable. And what's the next part of the IVT we show? The between is complete. F of 7 F of 7, which equals 5, is greater than a place where F equals
0.
No.
Just like make up a.
4. We want to find a place that's same as somewhere else, so we're going to use 4. F of 4 is between an F of 5 and an F at 12, which is 1, yeah? So by IVT, there is a, what should we call it? There is a C? There is a C in what region of X value? 7 to 12, where F at that C equals 4. All right, now I established that there's another place where y value hits 4, right? Now we move on to our MVT. Get me started. F is continuous on the closed interval. I kind of already said that, so I don't know if I'll say it again just in case there's somebody on a bad day and getting picky. And differentiable on the open. So by MVT, there is a, and here's where it gets a little rough. So you have to be careful with the details. There is a C to, no, we've already used
K.
a K. There is a K where, in what interval?
0, or no, 4 to 5. No, 3 to 7. 3 to 7.
No.
5 to 12.
0 to
No.
12.
No.
Negative 2 to 1.
No.
3 to 5.
No.
3
3 to
1,
12.
2, 3, 4, 5, 6, 7, 8, 9, 10.
what's the right endpoint where it's going to be 40? Where does it equal 4? C. There's a K in 3 to C where
Good morning, Dublin Jaguar. Please rise.
F prime at that K equals, ahead, stop.
Begin.
I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all. Where F at C minus F at 3 equals C minus 3, yeah? And the F at C and F at 3 are? Oh, I'm not using row A, am I? Dang it. I'm just doing this in an MVT way. That's fine.
All students
I meant to use
are
row A.
invited and welcome to join counseling for a career session on Thursday, February 20th during 7th hour. The exciting subject of aerospace engineering.
It works. You can use MVT, although I intended to use row A.
Shuttle, NASA, International Space Station, weather
Go back and
satellites,
change
and
it.
much more. Hope to see all of you there. Please sign up on the
We'll finish going over tomorrow, or going over questions on both homeworks tomorrow.
Our incredible music